Hello and welcome to exam review for Algebra 1B. This section is a non-calculator section, so we will be graphing functions, whether they are going to be linear, quadratic, absolute value, or exponential. So number one, on your exam review handout on page 2 is y is equal to 2x minus 3. The first thing we're going to look at is, do we have, get my, oops, do we have an absolute value sign? And we do not. So we are looking at, is there any exponents? There are not exponents in this function, so we have a linear function. So the important thing about the linear function is that we're going to be looking at a straight line, and with a constant slope and a y-intercept. So bringing it back to Algebra 1a, we have the equation y equals mx plus b. Here, the b, which correlates with the negative 3, is going to be our y-intercept. So we're going to come down and make a dot. Our m is going to be our slope. And remember, when we talk about slope for a linear function, is rise over run, or y over x. The change in y over the change in x. So as we see here, our slope here is going to equal 2. So we are going to rise 2 and we're going to run 1. So from our starting point right here, we're going to go up 2, 1, 2, and over 1. We're going to go up 2 over 1. Up 2 over 1. I'm going to do my best to connect these dots. And there is our line. One way we can check our line, I know that my line is not going through this dot right here, but let's take point 2, 1, and let's put that back into our function to check it. So we're going to put a 2 in for x and a 1 in for y. So we're going to say that 1 is equal to 2 times 2. Again, that is the 2 for our x and our 1 for our y, minus 3. So we end up with 1 is equal to 4 minus 3, which is 1. And that is correct. That is part of our solution. So that point is definitely on our line, graphing this function. Number 2, we are looking at 5x plus 3y equals 9. Now again, one thing when we are graphing a function, we should always have our function as y is equal to something. So we have to do some algebra here to get our equation to say y equals. So right now we have the 5x on the same side as the 3y. So we need to get rid of that. So we're going to subtract the 5x from the left side. And remember, whatever we do to the left side, we need to do the right side of the equal sign to make sure that that function remains equal. So we're going to minus 5x. Why do we minus 5x? Is because as we minus 5x, it's going to eliminate that 5x. So as we rewrite this, we have 3y equals 9 minus 5x. Now we have 3 times y equals 9 minus 5x. So the way we undo a multiplication or a times is we divide by 3. The reason we divide by 3 is now, as we see here, 3 divided by 3, our 3's are going to cancel. We're going to be just left with y. So y is equal to 9 divided by 3 is 3. a negative 5x divided by 3 that's, is not going to simplify to a whole number, so we're just going to say 5 over 3x. Now we can rewrite that, so we have our y is equal to mx plus b. So we have y is equal to a negative 5 over 3x plus 3. Now again, I'll write up the y is equal to mx plus b. So again, our b, which is our y-intercept, is equal to 3. So we'll put a dot right here at 3. Our m, which is our slope, is a negative 5/3. So our slope is equal to a negative 5 over 3, which again is rise over run. So we have a negative here, so we're really not rising, we're dropping. We're doing the opposite of rising. So we're going to drop 5, 1, 2, 3, 4, 5, and run 3, 1, 2, 3. Put our dot there. And because our slope is so big, looks like we're only going to be able to get those 2 points. So again, we just do our best to try to connect those dots. And there we go. Number 3. So now we have something that looks like a linear function, but we have these absolute value symbols. Okay, that's these straight bars. Okay, so that means that whatever happens inside those bars, the result is going to be positive. If what happens inside those bars is positive, then it remains positive. If what happens inside the bars is negative, then that negative goes to that positive number. So here, remember with absolute value, we are going to have something that looks like a V. Now it could be a V that's right side up, or it could be a V that's upside down. Okay. Then the other thing, the first thing that we want to do, number 1, is find the vertex. Now the vertex is that point either at the top or the bottom of the V. Okay. For a absolute value function, the vertex is going to come from the number next to the x in the absolute value and the number outside the absolute value. Now the key point to remember here is that the x value for the vertex is opposite what's inside here. So our value for this vertex is -3, -1. So as I come over here, I go to -3, -1, and put my point right there. Okay. Now I come over here and I look at this -2. Whatever number is in front of the absolute value is going to be my slope of my V. So if we have a number that's larger than 1, the absolute value is larger than 1, then my V is going to be narrow. If it's less than 1, if it's between 0 and 1, then it's going to be a wide V. And then also, this negative determines that the V is going to be upside down. Okay? So our slope is a -2 or 2. So here, going to the right is a -2. So we go, again, this is just like a linear line. It's rise over run. So we go down 2 over 1, down 2 over 1. And we draw a line right there. Now for this side, we have a positive slope of 2, but again, it only goes up to our vertex. And right there we go. We're going to go down 2, left 1. Now that we are moving we are moving negative in both directions. So a negative over a negative is a positive. And so we do that twice. And again, we try to connect those dots. And there is our upside down V. Now let's take a couple of points and see if they work out with our function y is equal to negative 2 times the absolute value of x plus 3 minus 1. So let's take this point right here. We have negative 1, negative 2, negative 3, negative 4, negative 5. So we have a negative 5 in the y and a negative 1 in the x. So we have negative 1 comma negative 5. Let's plug those numbers into our y and for our y and our x and see what we come up with. So we have a negative 5 is equal to a negative 2 times the absolute value of a negative 1 plus 3 minus 1. Now again, we took our negative 5, we put it in for y, we took our negative 1, and we put it in for x. So per our order of operation, we need to do what's inside the parentheses here, the absolute value first. So we have a negative 1 plus 3, and negative 1 plus 3 is a positive 2. And then we're going to multiply that by a negative 2, so we have a negative 4. So a negative 5 is equal to a negative 2 times 2 minus 1. Now we're going to see that negative 2 times 2 goes to a negative 4, and negative 4 minus 1 is equal to negative 5. So we are good there. If you like, you can check more points just to see how accurate your graph is, which if you're following your proper slope, you should have no problems. Number 4, we have another absolute value symbol right here. But notice that we do not have anything on the inside with our x. So what does that mean? That means that that value for our x, the vertex for our x value for our vertex is going to be 0. So our vertex, we're going to find our vertex, is going to equal to 0. And again, the y value for the vertex is that number that's afterwards, after the absolute value sign, and that is 4. So we have 0, comma 4. So as we go over here, 0 up 4, 1, 2, 3, 4, and we put another dot. Okay. Now we look in front of the absolute value sign for our slope. We don't see a number there, and that is because our slope is 1 or a negative 1, right? Because we have that negative sign right here. The reason they don't write the 1 is because in mathematics, writing a 1 is what they call redundant. And just to save time for whatever reason, if it's takes too much time to write a 1, mathematicians decide not to write that 1. So our slope is a negative 1 or 1. Now again, it's going to be a negative 1 going to the right and 1 coming from the left. So let's start with going to the right first. We go down 1 over 1, down 1 over 1, down 1 over 1. Now again, remember your slope is rise over run. Okay? Down 1 over 1, down 1 over 1. Okay? Now coming from the left or going to the left, our slope is 1. So we need to have a negative over a negative which is going to be a positive, or a negative 1 over a negative 1, right? So we're going to go down 1, left 1. So we went negative in the y, and we're going negative in the x. Down 1 over 1, down 1 to the left 1. I should be saying left. Down 1 to the left 1, down 1 to the left 1. And again, just do your best to connect those dots. And my pen's going crazy. There we go. We should put our arrows on there. And that is our graph for our function y equals a negative absolute value of x plus 4. Notice how when we have a negative, again, we are going to have the upside down v. If there was not the negative there, it would look just like this, except flipped over about that point 0, 4. Number 5, so we've talked about a linear function, we've talked about an absolute value function. Now we're going to talk about an exponential function. And the reason it's an exponential function is because we see our x in the exponent. Okay? Now, when we have an exponent or an exponential function, we're going to have a constant ratio. Now, what ratio means is something that you multiply by every time to get the next number, okay? And here, our parent equation is going to be y is equal to a times b to the x, where x is our variable and y is our variable. A is going to be a starting point. B is going to be our constant ratio. Okay, so as we see here, we have y is equal to 1/2 to the x power. We only see one number here. Why is that? Because there really, again, is a 1 outside here, but they decide not to put that because it's redundant. Our constant ratio is equal to 1/2. Okay, so one thing we can do here is we can label our starting point, and you always start at 0 on the x, so our starting point is going to be 1. And our constant ratio is 1/2. So we're going to start with 1, and we're going to multiply by 1/2 at the 1 mark. So 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. So we can see that we're getting smaller and smaller and smaller. But we never, unlike my graph, we never go below that x-axis. We will never we'll never have a y value there. Well, let's go to the left of the y-axis, or negative x values, and we say when x is equal to a negative 1, x is equal to a negative 2, okay? So we put in 1/2 to the negative 1 power, and that is going to be equal to 2. Excuse me. That is going to be equal to 2. 1/2 to the negative 2 power is going to be equal to 4. Alright, so we plot that in there. So when x is a negative 1, y is going to be equal to 2. So we plot that point right there. When x is equal to a negative 2, y is equal to 4. We plot that point right there. And there is the rest of our graph. And that, again, is what we call exponential function. Now, because this number, our constant ratio, is less than 1, it's just like dividing, so it's going to be getting smaller. So we call this exponential decay. Number 6. Number 6 is a multiple choice, and it looks like we have a curve here. So whenever we have that curve, remember a absolute value is a v, one way or the other. A linear line is just a straight line. An exponential is this curve. Now that curve can either go increasing or it can decrease. Put arrows on all my lines. Okay, so we're looking at an exponential function. So right now I know I can cross off d because that is a linear line function. So now I'm left with a, b, and c. Now they all have the x in the exponent, or our variable is in the exponent. But one thing kind of sets c apart is that the constant ratio, remember y is equal to a times b to the x for an exponential equation. Our b for c is less than 1. And remember just on the last page when our constant or common ratio is less than 1, we are going to have a graph that is decreasing. So we know that our graph is not decreasing because it is increasing, so we know that C is not our answer. Now the next thing that we can look at is A. A is our starting point. Okay, and our starting point is when x is equal to 0. What is y equal? Y is equal to 1, 2. So y is equal to 2. So our starting point is 2. And we see here that b has a starting value or a value of 2. So b is our correct answer. So what would a look like? A would look a lot like this function right here, but is going to start or have a starting value at 1. Okay, see how right here that goes through at 1? So this would be A. B is this line right here. So B would be your correct answer. Number 7. So we've looked at linear, we've looked at absolute value, we've just looked at exponential. Now we're looking at something called a quadratic. What makes this a quadratic is our 2 in the exponent right there. Don't get quadratic mixed up with exponential. The quadratic has the number 2 in the exponent. The exponential has the x in the exponent. Now quadratics we're going to treat a lot like we treated absolute value. When we look at a quadratic function, we're going to have a number inside the parenthesis and a number just outside the parenthesis right there. And that again is going to be our vertex. Now just like on the absolute value, the vertex value for the x is going to be the opposite of what's inside here. So right here, our vertex value is going to be -1, and our y value for our vertex is going to be exactly what it says on the outside of the parenthesis there, and be a -2. So I come down here, I go to -1, -2, and I plot my first point. Now, and also like the slope on our absolute value, we have what we'll call our change in our quadratic, and that is going to be this number right here. The bigger that number, the faster our quadratic is going to increase. Let me back up just one step. Remember that the shape of a quadratic is what we call a parabola. It looks basically like a U, and the U is just going to look like that. Or again, the U can be upside down and look like that. The negative is what makes it be upside down for this one. And what we can do here is we'll just make a table. And on that table, the only thing that we're going to make sure we want to do is we want to put our vertex in our table. Our vertex is now in our table because that is definitely going to be a point on our line. And we want to go 2 x values to the left and 2 x values to the right. So let's go with -2, -3, and let's go 0 and 1. Now again, I went 2 to the left and 2 to the right. So I take my x value and I plug it in for x right here. So I have y is equal to a -3 times a -3 plus 1 squared minus 2. So a -3 plus 1 is going to be a -2. And when I take a -2 squared, I'm going to say -2 times a -2, which is going to be equal to 4. And then I multiply that by -3, which is going to be a -12. I'm going to subtract 2. I'm going to have a -14. And my graph does definitely not go down to 14, but we'll put our point as far down as we can show. We'll put a point right there. So let's do -2. So we say y is equal to a -3 times a -2 plus 1 squared minus 2. Now we put in the -2 plus 1, so that's going to be a -1, and -1 squared, which is a -1 times a -1, is 1 times a -3 is a -3. A -3 minus our 2 is -5. Now remember, one thing with our parabola is we have a line of symmetry. And that line of symmetry says whatever happens on the left side, the exact thing is going to happen on the right side. So as we went 2 to the left here, the same numbers are going to take effect when I go to the right. So we have a -5 as we go to 0, as x is equal to 0, and we have a -14 as x is equal to 1. Again, we can't graph all the way down to 14, and I'm going to do my best to draw a U. Now the difference between the quadratic and the absolute value is the quadratic has kind of this curve at the bottom where the absolute value is a sharp point. Okay, so that is not the case for an for a quadratic. Again, we have the upside down U because we have the negative out front for our change. Number 8. Here we have a 2 as an exponent, but we don't have what we saw last time in our vertex form. We have this x squared plus 4x minus 2, and what we want is we want y is equal to some number out front times the quantity of x minus h squared plus k. Now h and k are just letter representations of what our vertex should be. So in order to get from this form of a quadratic equation, also called a quadratic trinomial for the 3 terms, we need to complete the square. And the way we complete the square, so we need to 1 complete the square. way we complete the squares, we take y is equal to x squared plus 4x, and we put in this parenthesis, and we put our last term on the outside. Okay. We take the coefficient in front of the x, which is 4, and we take 4 and we divide it by 2. And this is equal to 2. And the next step is we take two and we square it, and that is going to be equal to 4. And what do? We take the 4 and we put it right here. So plus 4. Now, we're working on one side of the equation, so we cannot just add 4 to the one side of the equation because that would not make it equal. So as we add 4 inside our parentheses, we need to subtract 4 on the outside. So we have, simplifying everything, we have y is equal to x squared plus 4x plus 4 minus a negative 2 minus 4 is a negative 6. Now we're not quite to our vertex form of our quadratic yet. We need to take one more step, and that's going to be we need to factor our x squared plus 4x plus 4. Now remember, factoring involves writing our x, and our 4 goes in the bottom, and our 4 goes in the top. Remember, we need to come up with two numbers that multiply together to get 4, that add together to get also 4. Now these two numbers, these might be different on your exam, but remember, whatever is connected to the x goes in the top. Whatever does not have an x by it goes in the bottom. So I know that 2 times 2 is equal to 4, and also 2 plus 2 is equal to 4. So we rewrite this as x plus 2 times x plus 2 minus 6. Now the way we simplify x plus 2 times the quantity of x plus 2 is we write x plus 2 squared minus 6. Now we have our quadratic function in vertex form. Again, our vertex is our highest or lowest point on our U. And the U is going to be what I'll call right side up because we have a positive number right there. So our vertex is equal to the opposite of what's inside our parentheses, so a negative 2 for our x and just the negative 6 for our y. So we come over 2, down 6, and there is our vertex. From there, I'm running out of room here, so I'll come up here. We'll just make our table. Again, our table should include our vertex, which is negative 2, negative 6. And we want to go 2 to the left, which would be negative 3, negative 4, and 2 to the right, which would be negative 1 and 0. Now again, remember, one thing that's going to save you a lot of time is our line of symmetry. I'm not too sure if I spelled symmetry right, but again, symmetry is whatever is happening on the left side is going to be the same on the right side. So I'm going to take 0 because that's going to be the easiest to plug into my equation. Now again, I can either plug it into my original function or this function down here, but as I plug in 0, I say y is equal to 0 plus 2 squared minus 6. So 0 plus 2 is 2. And I square that, which is going to be 4, and I subtract 6. So 4 subtract 6 is going to be negative 2. And I have a point right here. And I write negative 2 right here, and I put my point right there. And because I know my line of symmetry, if I'm 2 to the right of my vertex, as I go 2 to the left of my vertex, I'm going to have the same y value. So let's do negative 1. So y is equal to negative 1 plus 2 squared minus 6. Now negative 1 plus 2 is going to be 1, and the square of 1 is still 1. And so 1 minus 6 is a negative 5. And those are my other 2 points. So I have negative 1, negative 5. And I have negative 3, negative 5. I have negative 4, negative 2. And that makes my u. Okay, that is it for your non-calculator section of your exam. And I will make another video for the calculator portion.